Welcome, everyone, to today's Passive House Alberta Building Better in Alberta webinar series, sponsored by the Alberta Eco Trust. My name is Frank Crawford, and I am the Education Committee Lead for Passive House Alberta. Today, Cooper Lee, a Master Energy Advisor and the Senior Manager at 4Elements Integrated Design, will be talking all about targeting the higher tiers of the energy codes for multifamily missing middle projects. First, I would like to thank the Alberta Eco Trust for their ongoing support, and it is very helpful in allowing Passive House Alberta to continue our work. As always, you can place your questions in the chat box and I will ask them at the end, or you can unmute and ask them yourself. So now, please take it away, Cooper.
Hello, good to see a bunch of people here. Thanks, Frank and Passive House and Eco Trust for giving us the chance to talk to you. This is going to be just a quick little presentation about how you can meet code without going really too far into the weeds, as people think tier 4 and 5 is just unattainable. And obviously I won't get into our provincial government, but obviously our provincial government's not too on board. With that, I'll just move on to the presentation, because otherwise I'll just go into the weeds on it. As Frank mentioned, my name is Cooper Lee. I'm the Senior Manager here at 4Elements. I'm a Master Energy Advisor in all the different things you can be an energy advisor with Enercan, for EnerGuide, Energy Star, Net Zero. I have a lead background. I'm an IDP facilitator. I've taken moisture control technician courses at SAIT. I'm part of I've joined the retrofit course that they're offering this summer. I don't know, Frank, if you're also in that. I know you consulted on it. 4Elements as a company, we're a service organization for EnerGuide, kind of first and foremost, but we also do Energy Star, Net Zero. We've done lead work in the past, but lead doesn't have a lot of uptakes. We've kind of backed away from that. We have done a couple passive house projects and one shadowed living building challenge project. I would normally have a slide here for introductions for all of you, but I think because we've only got an hour today, we'll skip that part and jump straight into the building code. So we're focused on 936.7. That's the tiered energy code. That's what gives you the right to say, we did this much better than code. It's based on kind of the British Columbia step code, but nationally it hasn't been fully adopted yet, especially in Alberta. We're going to look at tiers 2, 3, 4, and 5, because tier 1 should be very easy to make. It is just building a code minimum home. Currently in Alberta, tier 1 or basic code compliance is all we've got kind of in place. So when it comes to but yes, for strictly for part 9, we're only looking at part 9 today. When you're doing these, so this table is straight from the building code 936.7.2. When you are looking at these paths, you kind of you have the heat loss reduction target, which is a requirement, and then you optionally can go percent improvement, so how much better you are than the reference house, or how much you've reduced the energy by with the home energy target. They're basically the same thing. You can see all those numbers there, they add up to 100%. It's just the metrics change slightly when you look at those two things. So the other part of the tiered code is the peak cooling load, which obviously Passive House is referenced forever. This in the National Building Code is a pass-fail. It is strictly a comparative from what you're gonna build to what the code minimum would be, and it is just straight yes, no. In our experience doing code performance modeling, we do roughly 2,000 homes for code performance a year. Roughly 40% of the homes that we model would not pass that peak cooling load. And that's part of why the Alberta government and Build kind of pushed against putting that into implementation. And then just a note that everything that we've modeled today does also pass that peak cooling load, because if we're going to look at code compliance, we got to look at all the metrics. This is just a nice little thing that we've put together, kind of takes all the different rating systems out there and puts them in a kind of comparator for energy efficiency and environmental sustainability. You can see Passive House on there right here, mostly because Passive House, and I will let you guys correct me later, I think is mostly focused on energy efficiency with a slight tint to sustainability. I'm sure Frank will give me notes on where it should move in this chart, and we're happy to adjust that as well with the experts. So just jumping straight in, we're giving you an example case today, which is a fourplex. It's a side-by-side with secondary suites, so 2 below, 2 above. We modeled it in HOT 2000, which is the modeling software that's required for the EnerGuide rating system. It's also referenced now in the new version of the National Building Code as a compliance pathway for energy performance. So we've taken this home and or this set of homes and modeled it to kind of what we call the Alberta typical construction. So that's a nominal R40 ceiling, nominal R32 or 22 watt bats in the walls, nominal R12 bats in the basements, and then R30 bats in the floors, any exposed floor. And then you can see on this table here, we've also put the effective R ratings in there, or R values in there, because obviously with framing and everything else, those don't reach their nominal values. And I know this group probably knows a little bit more about R values to know that effective is different than nominal. In terms of the mechanical, basic furnace, basic HRV, basic AC, basic domestic hot water, 2.5 air changes, which is the code prescribed value, although with attached, you can move up to 3. We like to keep it at 2 and have proper targets, and then code minimum windows 1.6 U value, 0.26 solar heat gain. This makes this house meet tier 1 by 0.6%. So it is exactly code compliant. You can see we've kind of given you a summary here of the total energy. So that's 222.5 gigajoules a year. It's about 60 gigajoules of that is just base loads because there are 4 units. The EnerGuide rating system assumes that is 2 people per unit. So 8 people in the house, 8 hours a day. We give you the heat loss here so you can see what that heating system size would be based on those assemblies and the mechanical systems and everything. Operational carbon is the amount of annual carbon exhaust or emitted into the atmosphere, and then the utility cost is based on August to August of 2023 to 2024 costs in Alberta, taken straight from the UCA website. So we take that, that's a basic model, that's where we start. So our goal here was then to get to the different tiers. This is what 4Elements calls an effectiveness table. We will take a bunch of different types of upgrades, put them into the modeling, model them one by one, and see how many gigajoules of energy each of those saves, what the energy cost savings would be, and then how much greenhouse gas savings there would be. And then obviously all of these numbers are taken on an annual basis. So we won't go through all these upgrades aside from to let you know this is what we modeled, so you can have a look at that later. I think I'll probably give the slides to Frank so that he can share them around for everybody, in addition to the recording that'll also be with this. So goal 1, hit tier 2. So we started at 0.6. Tier 2, we're looking to get to 10% better than code. To do this, based on our effectiveness table, all we really had to do for this house was put R24 bats in the walls, which put it to an effective R20, and then change the basement walls from a 2x4 to a 2x6, and then R24 there as well. And then a minor upgrade to the windows. This is basically the difference of going to regular doubles to moderate triples. So you can see there we got about 20 gigajoules of savings, 2 kilowatts of heat loss savings, and then the other numbers obviously come down in line as well. Feel free to throw questions in the chat. I'm happy to answer questions as we go because we're going to go through each of the tiers. So if you have a specific question about any of these, I know Frank already has some. So moving to tier 3, we get a little more aggressive on the envelope. We keep that R24 bat in the walls, but then we add an exterior wrap to the home. The product we put here is basically it's an inch and an inch and an eighth of polyiso. And then we add an insulation to the basement slab as well to kind of get that heat loss under control there. Improve the air tightness to 2 air changes instead of 2.5, and keep the windows at that basic triples. So we've now come down about 40 gigajoules, 5 kilowatts, and again, down in operational carbon and utility cost. Tier 4, this is when we start electrifying. So a lot of you are going to know that we really want to use the effectiveness of like an air source heat pump. So that's what we've got in here, kind of a mid-range heat pump here, 8 HSPF, 15 SEER. We've kept all the assemblies the same as in the tier 3 option, but we've now also upgraded the ceiling insulation to a nominal R60, so an effective R54, and then gone to a higher grade of windows here as well to reduce that heat loss a little more. Just to answer Joey's question here, as an energy advisor, I try to stay away from capital costs. Because we're not the ones building it, we don't often have our fingers on that pulse of things of what everything costs. We kind of leave that to professionals, the builders, the renovators. It's harder for us as consultants to get those costs a lot of times. I'm sure a lot of you will know that as well. Perfect. Yeah, thanks, Frank. So you can see here, we've come down in energy quite a bit. Again, the heat loss hasn't changed a lot, but the operational carbon and the utility costs here have gone up. And that is entirely because we've now switched the heating system to electric. So our carbon goes up because Alberta has a dirty grid, and our utility cost goes up because electricity as a unit of fuel costs more than natural gas in Alberta. And we'll see that again in the tier 5 one, although now we've really put a lot more into the envelope. Instead of what we were doing on the exterior with the polyiso, now we've added 2 inches of XPS for an effective R31 for the walls. And then the basement, we've put we've got it up to R31 as well by adding 4 inches of XPS below grade. Same ceiling, same basement slab insulation. We've switched to a higher efficiency cold climate heat pump now, and switched the hot water tank to an electric heat pump as well, with a pretty moderate 4.5 COP. Is not the most aggressive you can get on the efficiency there, but still a very good switch for efficiency. We've taken air change down to 1 because now we're looking at tier 5. We really got to get that energy in line. We're hoping we're not going to build this really good envelope and have a bunch of holes in it. A little bit better or higher solar heat gain on the windows to let a little bit more of that heat, that passive heat in to reduce our heating load. So you can see now the total energy load has gone down more than 50%. The heat loss has gone down about 50%. And now we're starting to really see those operational carbon savings and utility cost savings. So giving it to you here all in one so you can see the progress as we move through. Really just kind of incremental steps in energy efficiency savings, incremental steps in heat loss. And then you can see there's a jump in carbon and utility costs here when we switch to electric heat. And then that comes down again a little bit when we make the envelope that little bit better, make the air tightness better, and move to more efficient systems so that we get those costs down. So again, I ripped right through that. So we're gonna have lots of time to talk about questions. Biggest things, our conclusions on doing these projects are that tier 2 and 3 are actually pretty easy, especially on middle density and projects that don't go too heavy on the windows. That's one of the big things, is you're not going to meet that peak cooling load if you go too aggressive on your window counts, if you don't really do really good windows. That's either going to make you need to go with a really low solar heat gain coefficient, so you're not letting a lot of heat in, but then you're losing that heat in your passive heating. Tier 4 and 5 are going to require a lot more upgrades to the envelope. You pretty much upgrade every piece of the envelope, and then you're really going to rely on the mechanical systems to make up that efficiency. And then a note here, we don't include solar in this, and I believe Passive House is the same, because solar is not energy efficiency, it's just a fuel consumption reduction on site. So you're not actually going to gain any efficiency putting solar in, you're just going to pull less from whichever grids you're using, whether that's electricity or hydro or whatever else. And then a big note, this is our biggest note as people who go out and do a lot of blower door testing, building code does not require party walls to be sealed in any way, shape, or form aside from smoke and fire. That means often party walls don't get a layer of air barrier at all, and that's why you go in an apartment building, you can always smell what your neighbors are cooking. You walk in right away, it's just everything in that building. We start to market air tightness as more of an occupant comfort thing when it comes to multifamily, because without that cross leakage, you're not going to smell what your neighbors are cooking, smoking. anything else that kind of goes into that equation. And with that, I'm here for just questions. So ask away.
Thank you, Cooper. Excellent. I might ask a quick one to start. So
Yeah.
when is airtight testing required, or is it in the code?
So airtightness testing is required anytime. Currently in the code, it's required if you go in with a performance model and say you're going to do better than 2.5 air changes, or 3 if you're doing multi attached product. Once the tier codes come out, it becomes required for tier 3 and above if you're going prescriptive, and tier 3 and above if you're going performance, and if you're prescriptive, there are points in tier 2, and tier 1 has no requirement for air testing.
Okay. And yeah, I guess to kind of maybe circle back a bit more to the peak cooling load. So the peak cooling load, we want to make sure that we have, I guess, low solar heat gain windows, or more ideally, we have them correctly shaded, which is one of the passive house principles, so that we don't overheat in the summer, but can gather that heat in the winter.
That's right. Yep.
Okay. So really the reason that most of that 40% of your house are failing is because they have probably large west-facing unshaded windows.
West facing or south facing, and yeah, there are houses that just have that typical 1.5 to 2 foot overhang that is really just there for the aesthetics. It's not there to actually do any cooling or shading.
Okay. It was also interesting that if you go back to the energy, is that once we get down to the tier 4 and 5, we're only using 100 gigajoules of energy, and 60 gigajoules of energy is just the base loads. So we've actually reduced the energy the building is using from about 120 down to like 40. So it is a very significant reduction in the energy that's not base loads that we can't really change.
That's right. And that's why so while these numbers don't look like they're necessarily like the total energy numbers are not going to look like, so tier 5 would be a 70% reduction, but that's because when we do that math, we can exclude the base loads, because obviously that's a number we can't change. Houses just have base loads.
Yeah. And like Joey, you can jump on if you want, but it kind of, when we're talking about the cost savings, so yes, there are, depending on the tiers, some additional upfront envelope increases to get the higher performing envelopes and walls, but you can also see that the heat load from going from tier 1 to tier 5 has dropped in half, so you should be able to have a offsetting mechanical cost saving.
That's right. You end up with a much smaller system. Yeah, that's right.
Yeah.
And it, as an energy advisor, our baseline recommendation is always going to be, once you're moving up the tiers, you're not just getting a company to come in and give you a rule of thumb heat loss calculation for you. You want to get like a full CSA F280 calculation to size those systems correctly.
For those that don't know, do you want to explain what the F280 is a bit more?
Sure. Yeah, so the CSA F280 12 standard is a either whole house or room by room calculation of heat loss. Typically, you'll want to get that as the room by room, because that'll give you the full heat loss of the home and also give you the demand as it moves around the house. That is, so the CSA standard sets that. That's what the building code references. It's just no jurisdictions really enforce that as a requirement. It's what all homes are based off of, but a mechanical contractor will often use rule of thumb calculations that only take the square footage into account. Whereas a full CSA F280 calculation will have the assemblies as they're going to be built, the windows as they are, the facing direction, how much shading they have. It's a very accurate calculation of the home's heat loss, and then the heat gain as well. I will note that the numbers in the heat loss here are rough numbers. These are straight from HOT 2000, which is not a CSA F280 software. But these are, our experience finds they're within 10 to 15%. Did that explain F280 enough? I can certainly go into the weeds on that if people want more information on F280.
No, I think that's good for now, unless it comes up.
Okay.
So I think you kind of mentioned it. What software did you use to do this kind of optimization report, whatever you want to call it? And can like any energy advisor do it, or what's the training required, or what should we be looking for when we're getting people to do this?
Yeah, so we use HOT 2000, which is Enercan's software for modeling for the EnerGuide rating system. Anyone can download HOT 2000, but only an energy advisor can download. It should be using the version that allows you the full house reporting, but you can get all these numbers just in the student version. So any energy advisor is licensed to do these. But the full reporting that'll come out of that, an EnerGuide label or an Energy Star label or a CHPA Net Zero label, those have to come from a fully licensed energy advisor.
Excellent. Are you able to, now that embodied carbon is becoming more important to be thinking about, can you add on embodied carbon as another layer to these reports?
Absolutely. Yeah. Enercan has a tool out now that is called MCE squared material carbon emissions. I can't remember what the second E is. So it's basically an Excel program, but it'll take what we would put into HOT 2000 for the geometry in. And then once you settled into all the assemblies, it'll give you the full embodied carbon calculation from A1 to A3, I think, maybe A4 on that carbon scale. So it's a service that energy advisors are starting to get training in. CACE, the Canadian Association of Consulting Energy Advisors, has training out there for us energy advisors, and they've started walking us through that. We know embodied carbon and operation. We know operational carbon is coming in the next version of the code, and we know that the 2035 version of the National Building Code is looking at embodied carbon. So something we all got to look at.
Excellent. Is there specific like certifications for the EAs, or just ask that they've taken the training?
No, there's not even a requirement for training at all, but it is a pretty comprehensive Excel sheet. It's very similar to the Beam tool, if anybody's used that. Only it's fully standalone, whereas the Beam one, you go into a Google Doc sheet and it kind of goes from there. This is just a standalone Excel sheet that has all the EPDs. It has all the EPDs like in it, so that you can pull stuff from it directly.
Okay. And I guess roughly how much does this kind of service cost? Is it by square footage, by building? What's
for a preliminary model, most of our pricing and most other, when I talk to other EAs, it's either a base price or it might be based on the size or complexity of the home. This was a pretty easy one to do because it was more or less a square, because they were looking at efficiencies in the design as well as the assemblies. Our modeling for a preliminary set of results ranges anywhere from 350 to 1200, just depending on the complexity and size of the home. And then if you want this level of where you're taking all the tiers down, we typically will take that either at an hourly consulting rate, depending on how much work you want into it, or we can give you a full consulting package, which is usually another 800 to 1200, depending on the complexity or what you're looking for.
Yes, that sounds pretty reasonable for the amount of information that that you get out of it. And I guess to some degree, if the house is repeated, doing the energy model for any subsequent buildings that are repeated gets simpler.
Yep. Yeah, that's why we give you a range of that, and then we'll model as simply as we need to, typically just to meet the EnerGuide rating system requirements. But then if there's duplication involved, we don't charge a lot more for that, because it's not doing the whole thing over again. That's right.
Okay.
This is probably the quietest group I've had for a presentation in a long time.
Yeah. Don't, just because I'll keep talking, don't be afraid to raise your hand or just unmute and ask a question. Yeah, so I guess the unfortunate part of living in Alberta right now is that, yes, as we electrify our utility grid, electricity grid is dirtier than our gas grid. So I guess the way around this is solar.
That's right. As soon as you start putting that electrification in, it really makes sense to add that solar in, for sure. Because that's the, once you get to these, I don't know where my presentation up there. Once you get down to these numbers, you're really not going to get any operational carbon savings or utility cost savings until you start offsetting the amount that you need.
Yeah, it's an unfortunate part of our grid that yes, but it does definitely add into putting solar, and then you can sell the solar at a higher rate in the summer and help reduce those utility bills more than what is here shown now, even though solar is not incorporated into the design.
Build that credit up over the summer when the sun is shining and burn it away during the winter when you're having to buy electricity for heat.
All right, well,
I can show you guys this table that Frank told me was too complicated. It is very complicated, but you can see, like in terms of the utility cost, where that jump is once you put that electric heat in.
Yeah, switch back to your presenter view.
Absolutely. Oh no, that's not going to show that. Let me just full screen this.
Or unhide it, I guess.
Yeah. Oh yeah, that's what I can do here. That's big. So, and again, the utility costs that we used are based on August 2023 to August 2024 averaged out, and that'll include some of the, like we've included the monthly charge for that. So that's why you start seeing a dip on the tier 5 one, because you've got the gas out. So there's no longer that monthly administrative fee for the gas. You know, that tends to be $400 to $600 a year.
Okay. All right, so I don't know if there is any kind of developers or those that might want to talk to some of the costs, but yeah, to get to kind of tier 2 and 3, when you're adding looks to be like 1 or 2 inches of insulation around the exterior, that seems fairly reasonable, especially because the code is going to be moving that way shortly. And yes, Joey, so if you, instead of, they were shown the polyiso, but yeah, I guess Cooper, if you want, you could talk a little bit about making Fire Smart Health and maybe using the mineral wool.
Yeah, so that will, I think, Greg, you might have to remind me, does mineral wool have a lower EPD than fiberglass? It does, right?
It's in the same range as most of the other foams.
Yeah.
I think EPS is slightly lower, polyiso and XPS is definitely higher.
Yeah.
So
your carbon is going to shift a little bit, but your energy efficient, like mineral wool over bats, that our values are the same. You're not going to see much for energy difference there, just cost, material cost. And then embodied carbon savings for sure, which obviously we didn't include any of the results of that in here, but you're going to see savings there. If the fire smarting, you're also talking about like on your party walls, which can often lead to better air tightness. You're going to see some saving there, especially around like if you are putty packing the boxes and stuff. I'm guessing you guys mean solely in the materials.
well, or Joey, is it more about kind of the resiliency piece of having more of a fire resistance exterior wall? I'm guessing.
I mean, resiliency is always great, right? But that's probably a long-term building code requirement. Okay, we'll go in order here. Metal roof doesn't tend to affect these. When we model, we tend to leave off the finishing so that it doesn't affect what a builder wants to put on as that final product. Metaling would reduce your reduce your heat islanding. It would make your solar install better, a little bit better for water shedding. I don't know if that affects, if that's the answer you're looking for there.
Yeah. But it would put the embodied carbon up slightly higher than
steel is going to be higher than shingles. Yeah.
Yeah. And yeah, I guess Cooper, having tested a bunch of buildings, can you talk more about kind of comfort and durability and longevity of other advantages of going to the higher tiers?
Yeah. Those ones are all pretty straightforward, but often hard to see. Higher insulation in your walls also means a reduction in sound transfer, almost always. So a house that is Any of the houses that we've tested that are net zero and then close to a highway or major thoroughfare, you can definitely, just walking into those, notice the sound reduction of not hearing cars driving by and trucks driving by, especially in construction areas. Obviously, with better air tightness, you get better air quality in your homes. The requirements for your HRV, ERV, and other filtration systems become a little less because they're not taking in so much from unconditioned source or mechanically ventilated sources. And then, like I mentioned before, if your party walls are well sealed, you get less sound transfer, odor transfer, and then heat loss transfer. We've seen duplexes out there where one guy keeps it at 20 and one guy keeps it at 15. Well, the guy at 15 is sucking heat away from the guy that keeps it at 20, keeping their bills lower, and the other guy's bills go up a little more because he's got some forced heat loss through that party wall.
Interesting. I guess, have you gone back much, and do you see possibly the degradation of the buildings using kind of the lower end windows specifically, where you have more condensation, or is that more of a building scientist?
It's probably more
role?
of a building scientist thing. We don't get a lot of callbacks for anything once we've done a final blower door test. We've had the odd builder here or there that calls us back for maybe a warranty thing where they've got attic rain, and then we go back to our blower door test and say, yeah, we did tell you your bath end was leaking, so that's probably part of it.
Okay.
But we do find, because we work with a couple production builders in Calgary, the second you start doing regular blower door testing and you have a result to look at, they tend to start doing better in the first, in the long term, because they now have a result to compare to. And then when they get a result that is worse, they'll want to investigate why that was.
So you can really use kind of the higher tiers in the blower door test as a type of quality assurance or quality control method.
Yep, absolutely. Yeah, I would say any of the builders we've worked with, they typically, unless they started really well, which has happened, but they tend to get roughly 10% better a year because they are looking at those numbers like, well, air tightness is the lowest hanging fruit for energy efficiency. It's just also sometimes the hardest one for a builder if they don't have good quality control metrics and checks.
Yeah, exactly. What you don't measure, or what you get measured gets improved.
Yeah, that's exactly what Brendan said there. Like, if you measure things, you have something to look at. And any of our production builders will give them a chart a graph every year it shows all of their houses plotted on it, and then a trend line. And when that trend line is going up or curving in a way, we try to help them figure out why.
Good. I guess a little bit of question on that topic. I'm sure you've been asked, but like when we go to these higher tiers, and in the discussion with like a track builder, a larger developer, what kind of loss are they looking at in terms of maybe like square footage? Does it start to become quite noticeable, or is it kind of just get worked into the design? Is that a complaint you hear when you do have to add exterior insulation, or have more thicker party walls, for instance?
Yeah, no, great question. I would say that is typically the thing we fight against first at the beginning the most. It is always well, to get to tier 5, I'm going to have to do 9-inch Larson trusses on the outside, and how am I going to do that? I want to do a zero lot. When we do our upgrade package, that's why we went with that 1 1/8-inch thickness, because this project that we modeled had narrow side yards. It's an inner city project that needed to kind of keep as much space as they could. We do see a little bit of pushback from that, or at least the misconception that to do that we have to go to 2-foot walls or 1.5 foot walls. But you can really get up to tier 4 without, or up to tier 3 for sure, without going too heavy on the exterior insulation and losing that square footage. Anytime a builder comes to us for their first net zero, it's always very much a builder's first net zero. They keep the design really simple. It doesn't always look like a typical Calgary suburban house. Not a lot of corners, not a lot of windows, and then they do that, and then see, oh, actually, we could have done just a regular house. Their second house tends to be one of their next regular houses, with just a little more insulation, a little bit better mechanical.
Okay, so then the cost optimized version from their perspective is like somewhere in and around a tier 3.
You want to go back
And
to
then
those? Sorry, Cooper, do you want to go back to the kind of the tier 3, T4 effective R values requirements? And this is kind of one of the reasons why we did this the seminars, because we seeing this, it's not that much. It's an extra inch, 2 inches. So instead of a 6-inch wall, you go to an 8-inch wall, something like that. So
yeah, as I mentioned, this product that we've modeled is the Better Board product. A bunch of you guys probably know who Daryl Paul is. He's signed on with them to be their technical advisor, which is a pretty big feather in their cap. He's one of the more well-known Alberta building science guys. So it's got some good support behind it. A lot of what's in this particular upgrade tier is just cost. R24 is a bit of a premium over R22, R20. XPS in a basement slab is a bit of it's an extra cost. But to go back to Kim's question, we have noticed in any net zero house we've ever gone to site for, we've never seen a crack in a floor slab. That little bit of insulation under a floor slab gives it a little bit more structural rigidity, makes it so it doesn't crack, or at least gives it a little more resistance to cracking. So again, another potential comfort feature, or at least a homeowner conception piece, because cracked slabs always look bad, but cracked slabs are just kind of something that happens with our when we build really big, broad houses, big, broad slabs.
Yep. And I guess to kind of that comfort, and also to the heat loss, where we're reducing it by 5 kilowatts, is once you start putting some insulation underneath your slab, maybe you don't need to do that in slab heating, and that mechanical system can totally vanish, and you can just use your like a forced air furnace or something like that. So again, so you got to look at it holistically.
That's what, yeah, that's again a comfort piece, right? Like with a basement floor slab with even just 2 inches of EPS or XPS is always going to feel on your feet, even if it's unfinished concrete. You're not going to feel the cold transfer from the ground underneath. Like you can always keep your shoes off in those. If you go to, like as an example, if you go to any of Jamin's show home parades and take your shoes off and go into a house that is the net zero, that has the slab insulation, and one of their houses that is not their net zero, is their core performance spec and doesn't, you'll feel it in your feet.
Yeah. So as we're sticking to this place where we're missing middle, where someone is living full time in that basement,
Yeah.
that little bit of insulation underneath the slab will definitely improve the comfort for that tenant or occupant of that basement suite.
Even if it's purely psychological. That's right. Yeah. Lanner's got a question about, or a comment about air tightness. If you're always going to say 2.5 or even the 3 if it's an attached, you should have the requirement for a blower door test. The caveat to that is if the person building it that's dealing with the inspector has negative interactions with the inspector, and this has happened to us more times than I'd like to like put out there in the world, an inspector can call for a blower door test on the results of any home, even if it was modeled to performance minimums. If they have a good reason to doubt that you would have hit that energy target. And a lot of the times we've seen it on like a custom builder doing a duplex, and the home inspector or the city inspector knows that there was nothing in the walls, they'll call for a blower door test. And then we've had some projects that went in prescriptively that had, or performance minimally, and had to adjust the modeling once the blower door test was done because they didn't quite meet that metric.
And is a blower door test is fairly cost effective as well, or is it more complex when we go to these missing middle buildings? Like, can anyone do a missing middle blower door test, or is it more complex in a standard single family home?
It depends. I mean, there's no building code requirement for a professional on a blower door test. So anyone that has a blower door kit can perform a blower door test, as long as they show. I think a municipality is only going to want to know what testing standards it's to, although I wouldn't say they're sophisticated enough to know the testing standards. But if you're doing like an EnerGuide label or any labeling, that has to be a licensed energy advisor. And then separate to that, if you're doing missing middle and it is a MERB, so it's attached with any stack to it, so like these, that has to be an energy advisor that is also certified and licensed for MERB testing and labeling.
Question about, yeah, where and when is a heat recovery ventilator needed? When did you put those in, or do they all have them?
For these, anything we model, we will always recommend an HRV. There's, as an energy advisor, I don't see any reason to not, because as soon as we're emphasizing tested or better air tightness, well, now you've taken out that the whole house has got to breathe option, or a metric that, you know, a lot of us fight against a lot, I'm sure. So you want that now mechanical ventilation, especially in a home that may not have the furnace turn on for 4 or 5 months of the year, in which case you're getting no ventilation unless you're opening windows. So every one of these models has an HRV in it.
Excellent. And yeah, question with from Salib. So because we have the spark gap and a dirty grid, what is the reason why we are needing to go to electrification for the higher tiers?
Efficiency, fuel efficiency is the big thing. Yeah, it's purely because, you know, a basic air source heat pump is roughly 200% more efficient than a furnace, a natural gas furnace, in terms of fuel use. It is purely to bring the total gigajoules of energy down. That is why we ended up with higher operational carbon and utility costs, because we were agnostic to the fuel, but the fuels do have different costs for sure.
All right, Chelsea, a question.
Go ahead. Yeah, I was only going to note that this tier 4 option would be, as if I was taking everything holistically, it's not a good option because you're keeping the gas solely for the hot water tank.
Yeah, so you're using it not that much, but you still have that fixed natural gas connection fee. So kind of keep the gas as long as you can and use as much of it because the unit rate is less.
Yeah.
But then when you get rid of it, you need to completely get rid of it.
Yeah, we modeled a home last year where they wanted to go full electric, but for whatever reason, the homeowner wanted to have a gas fireplace. And that gas fireplace uses 10 gigajoules of natural gas a year. So they were basically going to be paying $100 a gigajoule for the year.
Because of all the fixed fees divided only by.
That's right. Yeah.
Divided by
Amortized
10.
over the year. Yeah. And if that fireplace has a pilot light in it, well, that's 6 gigajoules a year of just pilot light heat.
Yes, in the summer and the winter.
Yes. Yeah, just for the year, for the whole year, in which, you know, as a comparator, 6 gigajoules of energy is 12 propane tanks. So it's a propane tank every month just to keep the pilot light going.
Interesting. Chelsea's question, what are some consequences of poor design they have seen that are based on typical mechanical envelope approaches for new builds that come across your desks? Like, I guess, what are some designs that you see all the time that don't work, or what are some designs that you have seen work?
The biggest thing we find when builders start moving to high performance and testing in general is the mechanical contractor, almost entirely the mechanical contractor. When they put their duct runs and everything in, they'll often put them too close to the wall so that poly can't be sealed really well, or poly doesn't get sealed at all. That's like the biggest design thing that we see when we do mid-construction testing and site visits. In terms of just overall design, we see like I mentioned before, they often, a builder will take a whiplash to that first one and go really too far in the designing for efficiency, and then they build a house that's not their typical house. Makes it really hard for them to sell and market, and then they do the second one, which is a typical build of theirs, and get it to net zero as well. But you treat that first one as like a discovery house, which is not a bad way to go. You do a house really well, and then you take those efficiencies and move them onto your next design. Does that answer your question, Chelsea, or do you need me to give you more?
And I guess if we're looking holistically and going for net zero, then starting with a simple roof slope where you can put solar panels on it
Yes.
is another key.
Obviously, yeah, you want roofs designed for solar, not just roofs designed to meet architectural guidelines. If we were really smart about it, we'd go back to a nice little grid system and keep our houses so they're north and south facing. Nice big roofs to face the right directions for solar.
All right, looking through. Anyone feel free to unmute if I've missed anything or have any other comments to add.
In our experience, most of our builders do use the HRV in line with the heating system, and then also run a line to replace bath fans.
Yeah, so they integrate the HRV in with the furnace. And do
And
they
then-
need to run the furnace blower always on low, or is the HRV fan sometimes big enough?
The HRV fan is usually big enough. We've seen some do that lockout, but doing the lockouts tends to create other issues commissioning wise with our somewhat inexperienced HRV trades. This is one of the things I talk about a lot when we had the big cold spell in January 2024, and there were all the quote unquote heat pump failures across the province. All of those failures, from what we heard, or a lot of those failures from what we heard, were because of HRV integrations with those heat pumps. At least 10 of the ones in Edmonton were because the heat pump was set so that if the secondary system, so the backup system, was running, would not run if the HRV was running at all. And if an HRV runs 20 or 40 minutes an hour, that means for 20 minutes or 40 minutes an hour, the heating system just doesn't turn on. In which case it will never catch up to get you to 20, 21 degrees.
So commissioning of the mechanical systems to make sure that they were designed correctly and actually function correctly.
In addition to that, like the full actual proper design comment that I made earlier, you want to, if you're, I would never want to see a home with a heat pump that didn't get a sizing calculation done and was just rule of thumb out. The number of times we've had a builder come to us and tell us, our mechanical contractor says we need two 35,000 BTU heat pumps in this 33,000 square foot house, which is meeting net zero standards on all its assemblies. Well, that's impossible. There's no reason a house should need 7 kilowatts of heat on a new home.
Yeah. I guess what are you seeing for domestic hot water? Heat pumps, all electric, split systems?
Typically, we just see the full system, so it's just pulling from the room that it's in. They don't tend to be ducted anywhere else. We've seen some projects in BC where they've wanted to use that, like they've shot that out into like a cold room or something to kind of make better use of that cold air off those machines. But for the most part, just the basic one in it. We kind of try to point it out every time that like you don't want to make the mechanical room too small because that room's just going to be really cold with one of those things in it.
Yes, it's free air conditioning in the summer. You could try to duct it and use it, but yes, it does steal from the space heat of the house in the winter.
That's right. Go ahead, Brendan.
Yeah, no one's got another one. I'll throw this one out there. This could be a fun one for you, Cooper. So I was at the presentation and ATCO was there, and they were talking about potentially putting hydrogen in their mixed with their gas. And I'm curious if you've ever seen any numbers related to that or played with that in the modeling, like with that.
I
Yeah.
I don't think that Hot 2000 gives me a way to model hydrogen at all.
Mhm.
I know it's been kind of like for the Edmonton Blatchford projects in their district heating, and then a couple of them are looking at hydrogen. I know it's been kind of a big discussion among Energy Advisor. How are we going to model this? We don't really have a ruling from Enercam back for that yet. I know I was on the SRIA project review committee for this round of funding, and I know there were a couple hydrogen projects in that as well. So we're interested to see how those come.
Could you, yeah, I guess maybe the thought there was like, could you change the I don't know, not the efficiency of the gas, but the like in the model, maybe just like the intensity or the
not really on our side.
Yeah.
We just have like
Yeah.
when I go no model, it is just, is it electric? Is it natural gas? Is it propane? I think those are really the only three things that we can model for fuel, or wood. Uh, I've never had to model something with wood as its primary fuel. I hope I never have to, but we'll see.
Cool. Thanks.
Yeah, no problem. It was a great question. The Saria review committee got me kind of excited to see what could happen with there were there's a biomass project in there, and the hydrogen one as well, because that does have big district energy implications, at least.
Yeah, I mean, if we think about gas or like ethanol or gasoline, though, like, will that actually come out in terms of like by the time it gets to us as a cost savings? Like, would it maybe shift your line of your tiers over, or would it stay the same? That'd be a curious thing to model when we get more data.
Yeah, looking forward to that. And let us know if you hear anything.
No, sure.
We don't have our finger in every pie, so like we rely on coming to these things to get information as well. So
Excellent. Yeah, I think there is still a lot of with some of this new information with multifamily, looking at, do we keep gas? Do we go electrification? We didn't need as thick of walls as we needed, so we are still kind of fairly new into the building a high performance multifamily building. We've got a lot of experience with single families, but multifamily is still a little newer, so still some things to be learned. But I guess the biggest thing from today is don't be scared of it. It's not as bad as we thought for single families, or it's definitely not it's not as high a requirement as in single families because you have all those base loads.
And a couple of you brought up like when you are into an attached product, your baseline comparator for airtightness is 3. You're not quite the 2.5, so you get a little bit of a code bump leeway there. And I guess I didn't really touch on when you get to under 300 square meters per unit size, the metrics come down substantially. If any of these units were say above garage suite, the targets become much easier. I think if we had modeled the same thing as an above garage suite, it started at tier 3 with what we would have called our tier 1 spec in this model. So the metrics just get a little easier once you get smaller.
Okay, that's nice to give an advantage of being small, because in Passive House we kind of know that there's actually a disadvantage to being small because some of the metrics are harder to meet. So it's nice that some of the metrics are easier to meet.
And I think that was the code realized, because when we model this, well, under 300 square meters, that's still the same. If it was still this building and it was under 300 square meters, it's still 60 gigajoules of base loads. So your base load becomes a much bigger portion of your energy loss.
Yeah.
Or consumption, not loss, but yeah.
Yeah, and 300 square meters is almost 3,000 square feet. So that's, yeah. Missing middle, you might be there. Single family, you should be below it.
Yeah, and that, like, the important part to remember there, that's a volumetric calculation. It's not it's not area.
Oh,
sorry, it's
cubic meters.
It's cubic meters, not That's when the volume is out, because acknowledging that your heat demand is based on volume, not floor area.
Well, we managed to have 30 minutes worth of questions. We're getting near the end. Any other last minute questions? Just looking through the chat. I think we got everything.
I did throw that up there. If anybody wants to screenshot it, that QR code is all my contact information. So if you need to reach out, feel free to reach out.
Excellent. And this recording will be put up on the Passive House Alberta YouTube channel shortly. So thank you all for coming. Thank you, Cooper, for your always expert advice and knowledge. And hope to see you all at next month's Passive House Alberta Building Better in Alberta webinar.
Good. Thanks all.